The chapter 6 triangles part 2. So we are going to see similarity of triangles. In part 1 already we have studied similar polygons. Two triangles are similar if their corresponding angles are equal. Their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Clear? So two triangles are similar, their corresponding angles are equal and their corresponding sides are in the same ratio. You see this diagram, triangle ABC, triangle PQR. Okay, all the corresponding angles are same, equal. Clear? See, in triangle ABC and triangle PQR, angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. Okay, and all the corresponding sides are proportion. That means AB by PQ equal to BC by QR equal to AC by PR. Clear? Both the conditions satisfied means then you can say the two triangles are similar. Okay, this is vice versa. Conversely also it is true. If we if you have two triangles are similar means then you can write these two results. Okay, all the corresponding angles are equal and all the corresponding sides are proportional. Clear? That's why we can put this symbol. Both way it is true. Both way it is true. Understand? So very important this definition of similarity of triangles. So now we will see very important result. If corresponding angles of two triangles are equal, then they are known as equiangular triangles. See, when the two triangles, take two triangles, okay, two corresponding angles are same means automatically what? Third angle also same. Third corresponding angle also same by using angle sum property. That's why what? If you have two corresponding angles are equal means then immediately we can say these two triangles are called equiangular triangle. Clear? Equiangular triangle. Understand? So based on a famous Greek mathematician, Thales gave an important truth relating to two equiangular triangles, which is as follows. The ratio of any two corresponding sides in two equiangular triangle is always same. So corresponding sides, ratio of corresponding sides are also same. He also used a result called basic proportionality theorem. Basic proportionality theorem, that is BPT, that is Thales theorem. So next we are going to see Thales theorem, that is basic proportionality theorem. Okay, we are going to see very important theorem. Theorem 6.1 BPT means basic proportionality theorem, that is called Thales theorem. Okay, so see the statement. If a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, the other two sides are divided in the same ratio. So take any triangle, ABC is a triangle. The line is drawn parallel to one side of the triangle, that means DE parallel to BC. Here, that line divide other two sides in two distinct points. So the other two sides divided in the same ratio. That means AD by DB is equal to AE by EC. That is the statement. Clear? So you have to prove AD by DB equal to AE by EC. Clear? So this thing you have to prove. The other two sides are divided in the same ratio. Okay, now to prove this one is given in a triangle. Okay, line is drawn parallel to one side of a triangle to intersect other two sides in two distinct points, that is DE parallel to BC given. DE parallel to BC given. So you have to prove AD by DB equal to AE by EC. Clear? So given triangle ABC, DE parallel to BC intersect the other two sides AB and AC at D and E respectively. So to prove AD by DB equal to AE by EC. Clear? So diagram is very important. Everything is there in the diagram. Clear? You have to remember the diagram is easily you can write the statement, nothing. Clear? So sometime they will ask state and prove basic proportionality theorem. Means you have to write this statement also as it is you have to write. Okay. Now construction is draw EN perpendicular to AB. Draw EN perpendicular to AB and DM perpendicular to AC. Then join BE and DC. So this construction you have to remember. Clear? For this theorem, construction is very important. Without construction, we cannot prove. Clear? That is very important. So now how to prove this? You see the left hand side. Take left hand side. In the left hand side, what you have? AD by, this is AD. AD by AD by DB equal to AE by EC. So take left hand side. Left hand side you have AD. Here. So based on AE, you have one triangle. ADE is one triangle. Then denominator we have DB. So based on this, okay, DB, you have another triangle, that is what? BDE. BDE. Understand? So you have to take left hand side. Left hand side AD, based on AD you have ADE. Then DB, based on DB you have BDE. Two triangle area you have to find out here. So you write area of triangle ADE by area of triangle BDE. Understand? So first you take left hand side. Left hand side you have AD by DB. So in the triangle also you take this left side here. So here AD, based on AD you take one triangle, based on BD you take another triangle. Clear? For both you have to write area. So what is area of triangle ADE? Area of triangle means half into base into height. So what is area of triangle ADE? ADE triangle, suppose you take this is base means what is the height? The opposite vertex. From the opposite vertex you draw perpendicular to the base. So this is height of the triangle, that is EN is the height. So this can be written as half into base is AD into the height is EN. Understand? Divided by then you come to what this triangle BDE. Same formula, that is the area of triangle formula is half into base into height. So the half into the base is BD or DB also you can write. Here into what is the height? This is the obtuse angle to triangle. This one. Okay. So the height is same. That is what we extend this side. That is BD. You extend means this is this side opposite vertex is this one. So from the vertex you draw perpendicular to the base means you will get this EN is the height. Clear? So same EN you will get. Understand? Any what obtuse angle to triangle. Clear? You have to draw height means you have to extend this. Then from here you have to work. draw perpendicular. You have to draw perpendicular means this is what n. Suppose you take this triangle, okay, BDE means BD you extend. BD extend means, okay, this BD opposite vertex, that is E. You draw perpendicular means you will get height of this triangle. So this area of this triangle is off into base, off into base, off into base into height. Clear? Off into base into height. So base is dB, height is En. Clear? That is the height. This is the base, off into base into height. So the off into the base is dB, height is En. Understand? Same triangle BDE we have written like this. This can be written as area of triangle ADE by area of triangle BDE is equal to AD by DB. AD by DB. This is 1 you take. This is 1. Clear? Same way right hand side you have to do angle. And same way right hand side. AE based on AE, same triangle. Area of triangle ADE you write. Area of triangle ADE by area of triangle. Right hand side you have easy. So easy based on easy you take what a CDE. CD in order you take so that easily you can write CDE. Okay, here you see area of triangle ADB, ADE, area of triangle ADE by area of triangle BDE. So here same area of triangle ADE by area of triangle CDE. Understand? So easy to remember also. Okay, so the idea is very important. Clear? Idea is very important. So now what is the area of triangle ADE off into the base? The base is AE. Base is AE. Then height is when you take this base in this triangle, base is this one means this base opposite vertex, this one B. So perpendicular. Okay, the DM is perpendicular. DM is perpendicular. Understand? So DM. Height is DM. Same way, this triangle CDE off into the base. Base is what? Easy. Base is easy. The height is same DM because it is obtuse angle triangle. This one obtuse angle triangle. Here, that is CDE is obtuse angle triangle. We extend this CE. Extend this CE means same way. Clear? Draw perpendicular. Draw perpendicular to AC means you will get height of the triangle. That is same DM you write. Same DM. So DM get cancelled here. Off get cancelled. Therefore, area of triangle ADE by area of triangle CDE is equal to AE by EC. AE by EC. This is 2. This is 2. Okay. Now, what we have to prove is AD by DB equal to AE by EC. That means right hand side you have to make equal. Right hand side you have to make equal. So, for that what? First you have to make left hand side equal means automatically right hand side will be equal. Okay. For that we have in 9th class you have studied one property. Okay. Two triangles, that is triangle BDE and triangle CDE are on the same base and between the same parallel means both area will be equal. This area, this both 1 and 2 denominator area will be equal. Why? The two triangles on the same base and between the same parallels. There, 9th class that property we have studied, right? But area of triangle BDE is equal to area of triangle CDE. This one you take it as 3. Here, the reason you write. Okay, So this reason you have to write clear, for that mark is there. Okay. So both area equal means the reason you have to write triangles are on the same base and between the same parallels. Okay. So from 1, 2 and 3, from 1, 2 and 3, so you see the denominator, when the both what 1 and 2 denominator same, use 3, 1 and 2 denominator same, both left hand sides are equal means automatically right hand side also equal. Understand? See, from 1, 2 and 3. Understand? Use this 3 means left hand side will be same, because area BDE equal to area of triangle CDE means the left hand side will become same. Okay? Therefore, right hand side also equal. Therefore, right hand side equal means AD by DB is equal to AE by EC. Hence proved. Hence proved. So very simple, clear. So always you have to remember this theorem. This is what in 4 marks very important. Clear. Name theorem. They may also state and prove basic proportionality theorem. So the diagram is very important. Clear. Everything is there in the diagram. On seeing the diagram, easily you can write this theorem. Clear. First you have to take left hand side. Okay, left hand side what AD, based on AD, one triangle you take, based on BD, another triangle you take, both area you make ratio, means you will get AD by DB. Clear? AD by DB. Same way, this side also you have to do, means you will get AE by EC. Clear? Then these two triangles, that is BDE and this CDE, are on the same base and they between the same parallel, means these two area will be same. Clear? Therefore, both left hand side equal means automatically right hand side also equal. Understand? Very simple proof. Easily you can remember. So you can also do this type of activity. Clear? So easy to remember. You see this triangle. Clear? ABC is a triangle. D parallel to what? BC, and what you bring this triangle like this means left side you will get, you see AD by DB. Two triangles based on AD you have ADE, based on BD you have what BDE. Both having same height. Both having the same height, that is EN. Clear? Same way this side you take this triangle. This triangle you take. Clear? Based on AE. Based on right side what we have to prove AE by EC. So based on AE you have same triangle, that is ADE. Understand? Based on EC you have triangle what was CDE, triangle CDE, right? Triangle CDE. Okay, so both having same height, that is DN. Both triangle having same height, that is DN. Okay, so you have to apply the area of triangle formula, that is half into base into height. So this triangle what base, when you take this is the base means this is height, DM is the height. When you take this triangle means this one is base means same DM is the height, DM is the height. So for understanding purpose, clear, this activity is very important. Then both triangle, this triangle and what this triangle are having what same base and between the same parallel, Therefore, both area will be equal. This triangle, that is BDE, area of BDE equal to area of what? CDE, area of CDE. Clear? Then using that, easily we can prove AD by DB equal to AE by EC. Understand? So you can also do this type of activity. Okay. So next we will see how to use this BPT theorem. Clear? So in any triangle ABC, DA parallel to BC given. triangle ABC, DE parallel to BC given means immediately you can write by BPT, AD by DB is equal to AE by EC. See how you are taking the left side. Clear? Same way how to take right side also. Suppose if you take left AD by DB means right also you same way how to take AE by EC. Right? AE by EC. Now just adding one on both sides. What you will get? AD by DB plus 1 equal to AE by EC plus 1. So take LCM. Both side you take LCM means here what you will get? AD by DB nothing but AB. AE by EC nothing but AC. So the same thing you can write like this also. You can write like this also. Clear? So that's why how you are taking in the left. AB by DB means you have to take AE by EC. According to the problem, you have to take the ratio. Clear? Sometimes what you can take directly AB by DB equal to AC by EC. Understand? Or you can take like this also. Okay. Or DB by AB equal to EC by AC. Understand this left how you are taking. Same way how to take right also. Theorem 6.2 converse of BPT. The result is very important. Okay. Proof is not much important. Clear? You can easily prove also. But examination point of view, proof is not important. So for the time being, now see the result. How to use the result, that is very important. Okay, if a line divides any two sides of a triangle in the same ratio, just reversely you have to do. Okay, here in a triangle ABC, it is given ratio same. That means AD by DB is equal to AE by EC is given. This ratio is given. Clear? Equal. Given. So now what you have to do is by converse of BPT. If you have like this in triangle, this ratio if you have means immediately you write okay converse of BPT by converse of BPT. Immediately we can write DE parallel to BC. DE parallel to BC. The third side parallel. Clear? The line is parallel to the third side. So the line is dividing two sides in the same ratio. Then what? The line is parallel to the third side. The line is parallel to the third side. That only says this converse of BPT. Understand? If a line divides any two sides of a triangle in the same ratio, that is in the same ratio, then the line is parallel to the third side. That means two sides already you have taken. Third side is this one. So this line is dividing two sides in the same ratio. So automatically this will be parallel to the third side. So DE parallel to BC. Okay. So very important result. So you do the theorem 6.1. Clear? Without seeing you have to write. That is the homework. Clear? Do the homework 6.1 without seeing